Example 3. Two rails are represented by the equations x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Represent the situation graphically. Okay. So here in the question itself, they have provided two line equations, that is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. And they want to represent us the situation graphically. Okay. So in order to represent these line equations into a graphically, we have to require points. A point is nothing but the coordinates of x and y. So from these two line equations, we have to find points and we have to plot the graph for the two line equations by using the points. In the previous exercise, we have already done with the same question by finding the points and plotting the graph. So now we have to analyze what is the graphical report for these two equations, right? Okay. After plotting the graph for these two equations, we can clearly see that these two line equations never intersect with one another. That is, they are said to be parallel lines. They are not coincident with each other and they are not intersecting with one another at any point. This resembles these two line equations are said to be parallel lines. Okay. So the solution is represented by two parallel lines. Since the lines do not intersect at all, the rails do not cross each other. So this means the equations have no common solution. Right. Okay. So a pair of line equations which has no solution is called inconsistent pair of linear equations. And a pair of linear equations which have a solution is called consistent pair of linear equations. Similarly, a pair of linear equations which are equivalent has infinitely many distinct common solutions. Such a pair is called dependent pair of linear equations in two variables. See, here in the general terms, what are they? A pair of linear equations which has no solution. That is called inconsistent pair of equation. So here it comes under inconsistent pair of equations. Why? Because there is no common solution for these two lines. If the lines may intersect each other, so that a pair of line equations in two variables which has a solution, that is, they intersect with each other, so is called consistent pair of linear equations. And a pair of linear equations which are equivalent has infinitely many distinct common solutions. If a pair of linear equations are said to have infinitely many distinct common solutions, that is, these two line equations are coincident one with each other, which we previously see in the example 2. So such pair is called dependent pair of linear equations in two variables. Now, a dependent pair of linear equations is always consistent. So these are the technical terms for based upon the graph, where we can clearly note that there are three possible conditions happen by graphically when you plot two line equations. So they are: one, if two lines are said to be parallel, so that is, there is no common solution for the two lines. So such lines are called inconsistent pair of line equations. And if two pair of line equations are intersect at any point, so such that they have one common solution, so they are called as consistent pair of linear equations. And a pair of linear equations which are coincident with each other, that is, the two line equations in the graph is represented by a single equation, so that have infinite distinct common solutions. So such a pair is called dependent pair of linear equations in two variables. So these are the three technical terms we are using. And now onwards, in the previous exercises, they want to check us the given equations are consistent or inconsistent. So based upon these three, we have to find the solutions whether they are consistent pair or inconsistent pair of linear equations, right?